Best regards. I'll be introducing the phase B of the battle side of Capstone 1. In this case, the chassis subsystem. I will be discussing the following topics. For each subsystem, trade studies, architecture into components, trade study for critical components, risk assessment and project planning. For these operation diagrams, 3 different chassis alternatives will be shown. The 3 models were analyzed with the same material. The cost of the chromoly material was around $7 a pound, which was multiplied by the weight of the chassis. For this analysis, the following criteria were compared: cost, weight, weight distribution, material, stress, and displacement. This is the option 1 front braced frame. With the option 2 rear braced frame with the same material. And option 3 rear supported frame and with the same material chromoly. To establish which the best frame, we use the rating weighting decision matrix. As can be seen, the front brace frame had the best score over the other alternatives, with a score of 240. Although it's not less than its weight, but it guarantees a higher security than the others with the stress and displacement analysis. Criteria. The front brace frame is the best alternative for the design of the chassis. In the hierarchy diagram, it is subdivided into the material to be used and the adaptation of the subsystem, like a front rear suspension mount, engine components mount, bucket seat mount, seat harness, 5-point adapter, and the bullet adapter. Okay, the problem statement is the bar side rules require a maximum dimension of 64 inches width and 108 inches length. Also, the minimum and thickness tube are used for both the primary and secondary members of the frame. Both sides of the tube must be at least 1 inch diameter. Primary members are the major structural members and had to be at least 3 millimeters. The secondary members must be at least 0.089 millimeters. All the tools must be also made of steel with at least 18% of carbon. To solve the problem, we need to select a material according to the carbon percentage, calculate the max stress, max displacement, and safety factor. Must be resistant to all tests, like a drop from bottom, front, rear, roller, and top impact. The chassis must weigh less than 120 pounds. Designs must meet size requirements. And design must be strong and secure. For the selection of the material, these 3 alternatives were considered according to the reference found. They are compared with the following criteria, like a carbon percentage, tensile strength, ultimate and yield, modulo of elasticity, and density. As you can see, the high score was for the chromoly with a score of 280. Okay, in the risk, The chassis is the subsystem with the highest risk during the dynamic events. The chassis is heavier in terms of safety. The risks are adaptation to a subsystem for the letter A. Letter B, the chassis specification according with 2020 rules. Letter C, an unacceptable slip in drill holes. For letter D, the material failure. And letter I is the resistance for dynamic event like a drop from bottom, rear, and rubber impacts. So it can mitigate with the letter A. Another subsystem needs to communicate to maintain a design constraint. For the letter B, to design a chassis is necessary to follow the side rules. For the letter C, must extended beyond the two. Letter D, select a material is need a numerical evaluation to select the correct material. And finally, as for the letter I, chassis design need consider the driver safety. Okay, so our plan towards the next phase, phase C1, will be delivered on December 1. Thank you for your attention.